Okay, we are once back again. So today we will be talking about cache memory and the cache memory mapping techniques. So when we say cache memory, what is a cache memory? So let's have a brief history about. So cache memory is a small fast memory that sits between the CPU and the main memory, that's the RAM. So what's the purpose of this cache memory? This cache memory is responsible to store instructions or data that is frequently used by the CPU, so that the CPU can access the instruction or data quickly, reducing the time it will spend waiting for the data from the slower main memory. So we have three ways of doing cache memory mapping. We have the direct one, we have the fully associative one, then we have the set associative one. So all this so we have ways the address is being partitionized, ways in which the mapping is being partitioned. So the ways also used to define the mapping techniques, that way will help us to define the mapping technique. So let's quickly talk something about the the direct mapping. Let's quickly do something about direct mapping. So let's do something about direct mapping. Okay, so the direct mapping is the simple and the least expensive technique. It assigns each block of main memory to a specific or single location in the cache memory. So when we take the uh, when you take this direct mapping. So in mapping techniques, the cache memory, it has been divided into lines, and the main memory, it has been divided into blocks. So let's say we have 32 words in the main memory, then we have 16 words in the cache memory, then we have the words or the size of the block or the size of the line is 4 words. So it means this block contains 4 words. This line also can hold only 4 words, and this one is also can hold 4 words. And this one, how will I know the number of blocks for 32 words? So it's just simple. We have 32 words here, then we have 4 blocks. It means you divide the 32 by the 4, then you get 8. So it means we have 8 blocks for the main memory. So the line, how will I know the number of line? You take 16 words, you divide by the 4 words. So 16 divided by 4, you get how many? 4. 1, 2, 3, 4. That's it. So we have uh, four line also for the cache memory. So this is how we are going to do our lesson. So this is how this thing is. For you to know, it means this cache memory have how many lines? This the cache memory here have only 4 lines, and this one have 8 blocks. So it means the definition for the direct one, it means each block is mapped or located to a single or to a specific place. So we have to map each block here to a specific place. It means this line here, each line will contain 2 blocks from the main memory. Each line will contain 2 blocks. So how will I know say this block or this block is being located on this line? This is how we are going to do it. So this one, we will go back to mathematics where our module will work here. So let's say this is how we will do it. We will use our module. What's the size of this? This the number of line is 4. And then so you take the block number. This one is block 0. So 0, then the module. We are not now going to work over the module. You know our module 4. So you get 0. So it means this one here, it means this one will map to this one, and this one will map to this one, and this one will map to this one, and this one will map, sorry, and this one will map to this one. So 11 with 4 blocks. 4 blocks, we will do the same thing using the module. After doing 4 module 4, you will find out that this one will also map here, and this one will also map here, and this one will also map here, and this one will map here. This is how it is going to be. This is how it is going to be. So it means each line here will contain 2 blocks of the main memory. The cache memory, each line in the cache memory will contain 2 blocks from the main memory. Now we we are done with this. Now we know how the main memory will be mapped to the cache memory. So this is what now we are going to talk about what will be the total byte for the total byte for the physical memory, the total byte for the physical memory, and the physical memory, the total byte for the physical memory. It depends on the total number of the main memory, the total number, the total words of the main memory, the physical, sorry, the physical, the physical memory, the physical address. The physical address depends on the total, this it depends on these total words. So this is how we are going to do it. So we have 32 words. So 2 raised to the power what will give us 32. You find out that you find out that 2 raised to the power 5, 2 raised to the power 5 is equal to 32. Sorry, 32. It means this physical address means 32. Oh, sorry. 2 raised to the power 5. It means this physical address means it means 5 bits of address. It means total bits it will need is what, 5 bits. The total bit it will need is 5 bits, and this total 5 bits is being split for this one. We will share it, or we will divide this 5 for the tag, the index, and the block offset. So we will come and explain the tag, the index, and the block offset. We will explain that, so you get the understanding. So okay, we will move on to how are we going to also how are we going to split this way. How are we going to split this way? So let's come to the block offset, or this one. So let's come to this one. So the tag here, first let's explain the tag. The tag here, this is the function for the tag. The tag will specify the block, the particular block. This tag will specify the particular block which is in this one. This will specify the particular block which is in this one. And this index will also, let's come to this index will also point the will also direct us to the specific line which we can find the address. This index will direct us to the specific line in which we can find. So this index will direct us to the cache memory, the specific line in the cache memory. And this one will show the word, the specific word we are going for or we are looking for. It will show the specific word we are looking for. This will show the specific line in which the address is in, and this will show the specific address, and this will show the specific word in the address which the tag will specify for us. So this is how we are going to. If this one will show the specific word, so it means that what is the size of this one? The size of this one is what? Is 4. So what 2 raised to the power what? Will give us what? 2 raised to the power 2. Let me do it. 2 raised to the power 2 raised to the power 2. It means here we need 2 2 bytes 2 bytes of code. So this one will also, this one here will also show us the specific line in the cache memory where the address is, where we can locate the address or where we can locate the block. So this will show us the specific line there. And how many lines we have here? We have 4 lines. So what what number raised to the power 2 will give us 4 is also 2. So it means this one here will also need 2 bytes. This one here is also need will also need 2 bytes of code. 2 bytes of code. Yeah. This one will also need 2 bytes. So we left with the tag. And we are saying the total, and we are saying the total number here is 5. So we have to, then we will subtract this plus this, then we subtract it from the 5. So it will left with 1. So it means the tag will need only 1 byte to identify or to differentiate the the code we can, to differentiate which block is being found in a line. So it means this is how it means. This line, it contains how many block? This line contains, sorry, this each line here contains 2 block. So the tag here, this 1 byte will help us know the specific, uh, it will help us know the specific block it contains. So this block contains what block? It contains block 0, then block 4. So this tag here will let us know that the address that we are looking is inside block 0 or block 4. After this has direct us to the line, this will help us known as this. After the index, let me use my pointer. After this index has direct, the 2 byte of the index has direct us to the line. Let's say this index directs us to this line 0. So it has direct us to the line. So now it's time for this tag. So this tag will also let us know the kind or the block in which the word is inside. So this line contains 2 blocks. That's block 0, then block 4. So it will let us know that the word that we are looking for is is in block 0 or is in block 4, then uh, this block, this 2 bytes will also tell us that this is the word that we are looking for. This will specify the word that we are looking for. And we are saying each word contains each block contains 4 words. This block contains 4 words. This block contains 4 words. This block contains 4 words. So it means 0, 1, 2, 3, 4 they inside this block. 0, 1, 2, 3 dey inside this block, 4, 5, 6, 7 dey inside this block, 8, 9, 10, 11 dey inside this block. That is how it is up to 31, up to 31. So after this has specified either the this thing. Okay, let me do something here for you, for your understanding. Let me do. So this block contains what? 0. This line contains 0, comma 4. And this one contains what? This one contains 1, comma. It contains 1 and what? This one contains 1 and, let me see, I'm coming. 1 and 5. And this one contains, oh boy. And this one contains block 2, comma 6. And this one also contains block 3, comma 7. Block 3, comma 7. Okay, so we are done. So this line contains block 0, block 4. This line contains block 1, block 5. This line contains block 2, block 6. This line contains block 3, block 7. And we are saying we need only 1 byte to differentiate that the address that we are looking for is in block 0 or block 4. We need only 1 byte, and the byte that we need only 1 byte. So the byte will be either 0. Remember, all these are in binary. The byte will be in the 0 or 1, 0 or 1. So this is the byte that we need. Is either we need 0 or 1 byte to differentiate either the tag or either the address. We need 0, we need only 1 byte, and the byte will be either 0 or 1, because first of all we are dealing with binary. So the byte we need should be either 0 or 1 to differentiate either. So this is how we do it. So when we pick a number, or when the address is given, so if the last byte, okay, let me take decimal number 9. So the 5 byte of 9 will be 0, 1, 0, 0, 1. This is the uh, this is the binary number for 9. So it's how many? 1, 2, 3, 4, 5. So this physical address here need 5 bytes, and this one is also 5. So let's try and share it. And we are saying This one needs how many 2 bytes? This one will take 2 bytes. This one will take 2 bytes. This one will take 1 byte. So let's divide it. So two, 1. So you see, this one will take 2 bytes. Here is the 2. So this byte here will determine the word we are looking for. So this byte here will determine where, or will direct us to the it will direct us to the memory, to the cache memory, the line inside the cache memory. And this one will also tell us the specific block inside the cache memory. So let's see. So we have, let me, after we share it, we have 0, 1 here. So we have 1, 0. Then we have 0. So we are looking for 9. We are looking for 9 in this one. So now here it goes. This will tell us the way. So let's move on. This one will direct us to the cache memory, the specific line. So we have 1, 0. So when you check this cache memory, where we can find 1, 0. So 1, 0 can be found here. So it means this line contain the address. This line contain the address, but this line also contains 2 blocks. So which of the blocks does the address will be fine? So we will come here. This one is 0. So this one is telling us the specific block. So when we come here, when the byte or when the tag is 0, it means it's for address 1, address 2, sorry, it's for block 0, block 1, block 2, block 3. When the tag is 1, it's for block 4, block 5, block 6, block 7. So here the tag is 0 here, 0 here. The tag is 0 here, and this one has direct us to line 2. And line 2 also contains how many blocks? It contains block 2 and block 6. And we are saying when the tag is 0, it's for these blocks, and when the tag is 1, it's for this block. So the tag here is 0. So it means this line contain 2 blocks, and the blocks are 2 and 6. So and the tag is 0. So it means the block in which the address can be found is what? Is 2. The block in which the address can be found is 2. And here is the block 2. Now we have landed on a block 2, which so which word are we looking for? We are looking for 0. So don't forget, each don't forget each block is having 4 words. So let's say we have word 0, word 1, word 3. So we will have word 4, 5, 6, 7. So we had word 8 here, word 8. Sorry, let me. We had word 8. So word 8, word 9, word 10, then word 11. So when we find the binary for that word, it means the 01 will land on the word 9. The 01 will, so we will find the word 9 inside here. We will find the word 9 inside here. This is about the direct mapping. Okay, so we are continuing our lecture. So this one we are going to talk about the fully associative. We are going to talk about the fully associative. So when we say the fully associative, what that also means? What's the meaning of fully associative? So in the fully associative, it's like this one, the main memory. the blocks inside the main memory is not being mapped to a specific or a single location. It's being mapped, it's a random mapping. It can be mapped to any place or any line on the cache memory. That's the fully associate mapping. It's being mapped, the blocks inside the main memory can be mapped to any place or any line inside the cache memory. That's the fully associate. So let's go on. So let's move on to the last video. Let's move on to the last one. The last one is the set associate mapping. So this set associate mapping, this one also, this one deal with two ways. It's okay, sorry, this with three ways. That's the it deals with the tag, the uh, set index, then block offset. But for this one, it's a combination of the direct mapping and the fully associate mapping. It's a combination. So this is the reason it's a combination. This one, the lines in the cache memory are being divided into sets. Are being divided into sets. So it will be divided into sets. So it means this one we have how many blocks? We have four lines here. It means the lines will be divided into two sets, which each set will contains what? Each set will contain two lines. Each set will contain two lines. So the index here will rather use sets because the thing we are going to, the word or the address we will be finding will be inside the set, not the line. And also, this here can be mapped into any set it likes. No. This here will not be mapped to any set, but it will also use the modulo formula. So this, how are we going to know that this block here is inside this set or is inside this set? So this set will be something like 0 and this set will be 1. So this set will be 0 and this set will be 1. So how are we going to know that this how are we going to know that this block is being mapped to this set or is being mapped into this set? So how many sets do we have here? We have two sets. So we are going to use the modulo formula. So we will get to know that this set is here, this set is here. We will use the modulo formula. The number of blocks that you want to use, let's say two, you want to use block 2, then you use 2 modulo, 2 modulo, um we use 2 modulo what? 2 modulo, then the set, no, yeah, 2 we want to use, then it will be the set. So what's the set? The set is 2 set. So the answer you get, then 2 modulo 2 is 0. So it means this block will map to set 0. So you do the same thing for the rest of the blocks. So this one also, we need how many this thing we have here? Sorry, this one, the bytes needed for each year will be changed due to this one. We are not no more using the line, but we are concentrating on the set. So this block of sets here, which would direct us to the specific set, either this set or this set, which direct us to the specific, this block here no, will direct us to the specific set where we are looking for our this thing, the set where we are looking for our address. So this block here will direct. So now this block will depend on the set, not the line. The set, not the line. But this one, it's oh sorry. This index set here, which direct us to the specific set. This direct us to the specific set. So this will rather depend on the sets, the two sets, not the line. So this one is the same, this one is the same. So how do we find our bit? So this is how we find our bit. This block here, the block of sets stand for the word. So how many word? For 2 raised to the power 2. So it means we need the same 2 here. We need the same 2 here. So here now we are going to use the set. The set is 2. So 2 raised to the power what will give us 2. 2 raised to the power 1 will give us 2. So then we subtract. The rest will be for the, we will get 2. So let's do. So this one will need 2. It will need the same 2 bits. This one will need only 1. Then this one will need 2. This one will need 2. So let's take our binary, oh sorry, our uh, decimal line. Then no, the total is 5 bits. So we will have our 5 bits here. We'll have our 5 bits here. So we say this one, so this one will take 2, 0. Oh sorry, this one will take 2. This one will take 1. Then the rest will be for this, this 1, this 1, this 1. So this is how it goes. You can see that final, you see, this is how, it's not anything that difficult. This one will take 2, that's the 2. This one will take 1, that's the 1. And this one will take the rest. So we can see this is for specify the word, this specify the set, then this specify the address. So let's see, this will tell us that we should go to set 0, and this will tell us that inside this set 0, so we are now inside set 0. So this tag will tell us the word that we are looking for. The word is what? Sorry, the block. So here is the block. The block is 01, 01. You see, so when you come here, 01, you'll find it here. This is the block 01, because this one is mapped into this set, and this one can be, earlier we said this is the combination of what the direct one and the fully associated. So if this one is being mapped into this set, then it can be located, or it can go into any line inside this set. So it means when this one was mapped inside this set, it then finally come here. So this one has identified the line which we can find the word, and this one will identify the word, which the word will be 9. So that's all for our catch memory and catch memory mapping techniques. Thank you. The name is still Dedu Prince Kumi. Thank you.